Hello everyone, in this video we are going to solve an example related to the stress. This example is being taken from the book of Mechanics of Materials by R.C. Hibbeler. The problem number is 32. So in this problem it is being asked to calculate the average normal stress at 2 points D and E that you can see in this sketch, and also it is being asked to represent the stress on a volume element located at these points. So let's first determine the average normal stress at D point. So in order to calculate the normal stress at any point, we need force and area. So this is the point where we want to calculate. So first we need to know the force. Area can be calculated because the inner and outer diameter is given, because this pipe between A and B consists of built-up shaft. So to know the force, we need to cut at point D and take any portion. So in this case, I'm going to take the left portion. In order to balance this portion, we are going to have another force acting at this point, which will be of 4 kilonewton in order to have the balance over here. So this is the D point over here. So force is given, which is 4 kilonewton. Now area can easily be calculated. So stress at D point is equal to force upon area. Force is 4 kilonewton. So kilonewton can be represented as 4000 Newton force divided by the area. So outer diameter is 28 mm and inner diameter is 20 mm. So we know the formula to calculate the area as these areas in millimeters. So you can write it down in the form of meters as 0.028 square because of the area, and inner diameter is 20 millimeter. In meters it will be 0.02 square. So on doing the calculations, we are going to get the stress as 13.3 MPa. Since the nature of this force is compressive, so we are going to have a compressive normal stress because of compression force, and we can represent a volume element located at this point. So let's say this is the volume element. The element at point D is subjected to the stress of 13.3 MPa and nature is compressive. Now let's move on to have the normal stress at point E. So again we need to cut at the E point and then we have to take one portion. So in order to have the simplicity, I'm going to take the rightward portion. So when we have the rightward portion, at this portion, in order to have the balance, we are going to have a tensile force of 8 kilonewton, so that this element, EC element, will be in equilibrium. Again, in order to calculate the normal stress at the point, we need to know the force and area at this point. The force is just we have calculated is 8000 Newton, and we can calculate the area. Now here we can see this is a solid rod. The BC is actually a solid rod and that has a diameter of 12 millimeter. So we can then easily calculate the area as pi by 4 multiply by that square of 12 millimeter, or you can say 0.012 meter. So on doing the calculations, we are going to get the stress of 70.7 MPa, and the nature would be the tensile stress because the force that is being acted upon this point is of tensile nature. And the volume element located at E point can be shown like this. This is being subjected to the tensile stress of 70.7 MPa. So this is how we can have the normal stress at a point which is located on any loaded object. So this is all from this video, where we have learned about the calculation of average normal stress at different points in a loaded object. So that's it from me. Thank you for watching this video.